everything comes out okay. And Diego, is he not here today?
He's not here.
Okay. Alrighty, so a couple of orders of business. Number one, you guys need to take out last night's homework assignment, which is getting picked up. Yes. Okay. Paul is no longer on the naughty list. Yeah. Kevin is scared Paul. Kevin is fourth period, right?
Maybe.
If somebody, yeah, just set that off, Andy. Mario, syllabus, still on the naughty list. Sheila, where's my Sheila? Hi Sheila, are you going to stop by during lunch? Good.
You misspelled her name.
I knew it when it happened, and we're moving on. Okay, good. And Diego's absent. Okay, 3 things that you need to know. Those of you that are on a different naughty list, a much more important naughty list, are we filming? Okay, you have until Monday at the beginning of class to turn in any assignments that are missing or incomplete. After that, what happens is if you haven't turned it in, you're going to spend lunch with me every single day until it does get taken care of. Did this come through loud and clear? Yes, sir. Anyone that has not turned in all 3 parts of the summer assignment, this is AB and my BC friends, you will be with me every single day during lunch until it does get taken care of satisfactorily. And if you don't come for lunch, you have after-school detention. It's just the way that it is, and I do not like sending seniors to go hang out in the cafeteria with the 9th graders. Ugh. Who would want that? All right, so there's that. AB students, you have your first quiz on Monday.
About what?
BC students have their first quiz at 9:09. My solutions are on the table so that you can compare the work you've done so far to that. Make sure the men back there are sharing. Okay, AB students, here's what you need to know about the quiz on Monday. It's on everything we've covered so far. The first section is going to be about parent functions. And I think what we've discovered so far is if you know what the parent functions look like, not too bad. Is that pretty safe? Yeah. If you know what the parent function looks like, we're good. It's when you don't know what the parent function looks like that you're doomed. So this weekend, figure out all your parent functions. You get a survival guide for that. Second part of the quiz, bigger part of the quiz, is going to be 5 or 6 limit questions. And some of them are going to result in like 0 over 0, and you do some algebra trickery. Some of them you can just plug in. Some of them are going to be piecewise functions. You just have to know. And so here's what I'm doing to be helpful. I know you guys are going to thank me for this. This weekend's homework is to do assignment number 5 in the unit guide. I have no idea what page it's on. Can anybody find it? Assignment number 5. I think it's awkwardly numbered. I think where it says assignment number 5 is the bottom of page 59, but it's actually 60 and 61. Is everybody able to find that?
Oh, yeah.
Assignment 5, awkward. It's 60 and 61. Now that's a lot of problems. Now here's where the thank you comes.
Yes.
I am sending you my solutions to all of these problems on pages 60 and 61. And you're like, why would I do the homework? I'm not picking up the homework on Monday. You have the quiz on Monday. The homework, Sheila, is preparation for the quiz. Is this coming through loud and clear?
Yes, sir.
This is a good thing for you. Use it wisely. The smart kids are going to be the ones that spend maybe 30 minutes tomorrow working through some of these limit questions. And then another 30 minutes on Sunday working through the limit questions and then comparing to my solutions. That's good studying. That's really, really good studying. Pretty good?
So
Yes, sir.
Will you just have the solutions, or will you have like the
Oh, I'm going to have like the worked out solutions, not just like answers. Okay, other questions that are out there while I'm taking attendance? Jose?
The quiz on Monday, is it going to be multiple choice or?
A little bit of everything.
Okay.
A little bit of all the things. All right, if you guys could take out your calculators, we need to do a calculator check. Yes, and then over here.
So you would recommend like for at least 30 minutes?
At least 30 minutes tomorrow, at least 30 minutes Sunday. If you don't do that, it's not going to be enough. Okay? Oh, that's a bummer. Yes?
Yesterday I tried to watch the video,
Yeah?
but I had to move the camera closer because certain people's heads were in the way. So
Certain people's heads are in the way, so moving it closer
yeah.
would be helpful. Karina, would you be okay with managing the camera? Marilyn, are you okay with getting fired? Have you been fired before?
No.
Okay. This is the first one. Okay. All right. There is, oh, so many things happening. I am delivering. Oh, poor baby. All the things happening. Okay, hold on. If I can get all the voices off, please. Okay, so we're going to do this growth mindset survey. This is going to just get, you've done this before, you've done it like 3 years in a row now. It's not for a grade, there's no wrong answer or right answer. This is just how you feel about math. And I care greatly about how you feel about math.
Your head gets in the way.
Yeah, I do. There are no right or wrong answers. I'm going to deliver the Scantron, because this is where you need to put the answers. While I'm doing that, I'm also going to do the graphing calculator check. I need you to have your calculator so I can see that it's on. Okay? We're going to do this as quick as we can because I want to get rocking and rolling. Jeanette. Where's my Jeanette? Here you go, honey. Just leave it on the desk. Diego's not here. Jackie Baron. Here you go. Nice catch. Sheila. Okay, Paul. Chris. Bell. All right, Gerardo. Jerry. Beto. Karina. Henry. Where's my Henry? Henry. Jesus Martinez. Jesus Ortega. Jose Perez. Sylvia. I know Sylvia. Sylvia is over here. Sylvia with great suggestions. Andy. Adrian. Jose. Marilyn. Daisy. Melissa. Abraham. Oh, Abraham's fourth grade. All right, BC friends. Quick, are you done survey? Somebody the other day turned in this assignment and there's no name on it.
Oh, that's mine. That's mine.
Okay. Thank you, Jeanette. And Andy. If we could be done with the survey in about 2 minutes, can you guys just show me if the calculators are on and they work? Good? 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 Calculators over here, we're working? Bing, bang, boom. Calculators over here working? Good? Good? Oh, good. Calculators over here working? Bing, bang, boom. Calculator, calculator.
Yes, I do.
Slide paper. Back desk. Okay. Calculator working?
person wants to make deep? Well, I don't know who you want. You want to make deep? I don't know if he wants to make deep, but I don't think he's deep. I'll make deep. Just for you.
Yes.
I made a deep for the tax and reverse it.
Okay, I got you. All right. Handy paper picker-upper that you are, if you could go around and pick up all the surveys, please. Yeah. Recycling? Thanks. Alrighty, friends. Okay, basically your quiz starts at 9:09. So use this time wisely. Okay, AB, friends. Let's get back to the business that we were working on yesterday. Okay, so I'm on page 12 in the unit guide. Andy's coming around picking all this up. So I'd love to hear from you guys right now. Monday, Maryland, the quiz rolls around. You are faced with a whole bunch of problems that involve limits. I'd love to hear from some of the friends in the room. What do you do? What are your options? What might you do to figure out the answer to a limit? Chris?
Either like, it could be equals 0 plus 0 over 0. Just, what's it called? It's that word,
0 over 0. He's looking for a fancy word here, I think. If you see 0 over 0, that's that indeterminate form. If you see 0 over 0, well, you need to do some algebra. Maybe it's distribute, maybe it's factor, right? But I think before you get to 0 over 0, there's something you've tried first. Plug in, right? Technically, we call it direct substitution. Plug in. That's usually where I go first. Can I plug in? If I plug in and I get 0 over 0, do the algebra. But what else might you do? In this world of limits, what else could we do? Yeah.
If you have a limit like of infinity or negative infinity,
Yeah.
you can use the exponents to see.
Oh, if you're doing like limit as x approaches infinity or negative infinity, maybe there's some tricks from pre-calculus that we remember. Agreed. What else? Jose?
Maybe look like at the type of equation that it gives you,
Yeah.
and like maybe try to relate it to the parent function, and
Right, those parent functions, if the graph I'm asking you to look at is a parent function, you know what to do because you know about parent functions. There's something else that you might try doing. Go for it, I gave you a hint here.
Yeah, put it in the calculator.
You might plug it into the calculator and like do the limits and build the table, and Jeanette, we're okay with that? Now please don't do that, Adrian, I want to make sure this comes through loud and clear. We're only going to use the calculator if the problem says use a calculator. If it doesn't say use calculator, you cheating. Don't cheat. Okay, so here's the thing. Where we moved to yesterday, we went into this whole new class of problems that I call graphical analysis. And the world is different here. And I think right now, most of you probably don't even know, how do I know it's a graphical analysis question? So at the top of page 12, there's a couple of things that when I see them happening, I know, oh, let's try graphical analysis. If I see limit as x approaches infinity, or limit as x approaches negative infinity, if I see that it's infinite limit stuff, plugging in is now not possible. Right? We don't plug in infinity, that makes no sense. So we think about parent functions, we think about shortcuts. Another thing is if when you plug in direct substitution, if you get some number divided by 0, like 6 divided by 0, 12 divided by 0, this is a clue to me. I might want to try some of this analysis stuff. If I see domain restrictions, I know that's a fancy word, but domain restrictions, things about the function that say, oh, there's some special numbers I can use and there's numbers I can't use. For example, when I see square root signs. What's the domain restriction when it comes to like working with square roots?
Oh, you can have negatives.
No negative numbers, right? So that's a domain restriction. If I see division, if I see like stuff over stuff, the domain restriction with division, we don't want to divide by 0. Divide by 0, the universe explodes. Okay. If I see natural log of stuff, there's a domain restriction. What's the domain restriction here?
0.
There's something about the log graph. Can you guys draw it in the air for me again? That natural log graph. Natural log does this, right? What's the domain restriction with natural log?
There isn't?
There is a domain restriction with natural log.
0?
Not just 0.
Negative.
You cannot find the natural log of negative numbers. You can't find the natural log of 0, so there's a domain restriction there. I might be thinking about this graphical analysis. The last piece, and I don't remember if I introduced you guys to the word yesterday, is when you see parameters. Not variables, but there's going to be letters like A, B, and C, and we're going to look at one of those right now. Okay. So those are the visual clues for me that something else is going on here. So here's what I want you to do. I'm going to get the BC students set up with a quiz. I'm going to ask you to do these two first using your calculator. See what you can do. Get help from the peers. And then we're going to do this again, Jose, in a no calculator setting, and I'm much more interested in that. And Karina, is everybody able to see what I'm... If you want to move the camera forward a little bit so you can see it, that'd be good. So everybody's taking out the calculator. See what you can do. I'm going to go scare the BC kids. Okay. I'll tell the jokes here. I'm much better at it. All right. So, men in the back, friends up front.
Each one? Each one from the game. Who else is there?
In a way, I'm
Graphical analysis. No. Just gonna decide instead of like evaluating it.
We're gonna switch roles, you'll see things.
It does.
Is it not changing?
Sorry. I got to give you an answer.
Overflow.
All right. All right, from walking around, it looks like some people have gotten a good start on 1 and 3. Some of you seem to have come across an answer. Some of you maybe are still graphing it on your calculator. We're going to go without the calculator for a little bit. And I really want to push your thinking here, and it's going to be okay. I have faith. This first one's a whopper. Okay, so without calculator, here's where I would start. I'd say, okay, self, I'm being asked to find the limit as x approaches infinity of, can we agree this is some nasty ugliness here?
Yes.
No one in the room is supposed to know what this graph looks like. There are no shortcuts. There's nothing from pre-calculus that you can bring here. However, I want to figure out like what's going on here. As x is approaching infinity, the first place that x appears is over here in the e to the negative x. Does anybody know what happens here? As x approaches infinity, what's going on with the graph of e to the negative x, Henry? Okay, and if you're not sure, sketch out the graph. There's e to the negative x. What's happening, everybody? What's happening as x approaches infinity? E to the negative x is approaching something. I heard 1. It's not 1. 0. Now I want to be really specific with my flavor of 0. Are we greater than 0 or less than 0?
Greater.
Clearly greater. So I'm going to indicate this as 0 from the right. Now some of you might be like, oh cool, the answer is 0.
No.
Paul, not 0, right? Why not 0, Paul? I'm going to look at the rest. So what happens next? Now I'm multiplying by pi, so I want to know about pi e to the negative x. X is approaching infinity. E to the negative x is approaching 0. So what about pi times e to the negative x? If this part's approaching 0, and I multiply by pi,
It's still the same.
isn't that still 0? Positive or negative?
Positive.
Positive. And Paul might be up front saying, yay, I was right, 0.
No.
No, you keep going. Now you say, oh, but what about the natural log of pi e to the negative x? Bless. No one knows what the graph of natural log of pi e to the negative x looks like. But we all know what the graph of natural log looks like. So if the pi e to the negative x is approaching 0 from the right, what happens on the natural log graph? If you're not sure, go to that survival guide. Get close to 0 from the right, and what happens? I heard it from a lot of different folks. You're approaching negative infinity. Negative infinity, not the answer. Because you still have to figure out what happens with the sign. So, hold on one second, Henry. So the sign of the natural log of pi e to the negative x. What happens if what I'm taking the sign of, the stuff in here is approaching negative infinity? What happens to the sign graph as you go towards negative infinity, Jose? What happens?
Oh, towards negative?
Yeah. Think about that sign graph.
It goes like...
It's going like this, right?
Yeah.
What's that doing?
Oscillation.
Oscillation. So your answer here?
Does not.
Does not
Does not.
The limit, right, so here we see oscillation. So this is does not exist because of oscillation. Nice job. This is not what we were doing in pre-calculus. We are upping the game here, but it's all about parent functions. All right, so let's take it again to this number 3 here. For a not equal to 0 and b not equal to 0, these are the things that I'm talking about that are parameters. Parameters. I want to evaluate the limit as x approaches infinity of a divided by 1 plus b e to the negative 0.5x. And here's what I think happens. No one was able to graph this on the calculator. Why not? Because of like these extra letters, right? The A and the B, the parameters cause you to not be able to graph it on the calculator. Now, some clever students who did really well on the SAT, you see problems like this and you're like, I know what to do. They told me something about A, they told me something about B, Why don't I just pick something for A so I can graph it on my calculator? Why don't I pick something for B and graph it on my calculator? Does that make sense?
Yeah.
That's good, that works. But let's do it without doing that nonsense. Okay, so let's get started here. We got parameters. I want to know as x approaches infinity, let's get some hands on this. What happens first with the x? What's going on here? I see one person, I'm worried. I see two, I see three. Daisy.
You go to where you first see the x, which is
This e to the negative 0.05x? So what happens? Think about the graph here, e to the negative 0.05x. If you don't know what it looks like, it's okay. Go to the survival guide. X approaches infinity. What does e to the negative 0.05x look like? I see one, I see two, I see three. Some people are sketching it in the air. Yes, ma'am. Is it going to be 0? Absolutely. The graph of e to the negative 0.05x looks just like this guy over here. Here's the good news, Jeanette. We've just figured out what the e to the negative 0.05x looks like. We're approaching 0, and I bet a lot of you know exactly what to do next. E to the negative 0.05x is going closer to 0. Now what? Add b? Multiplied by b. So the next stop is to figure out, well, what happens to b e to the negative 0.05x? That's still 0, right? Great. Still 0. Daisy.
I have a question.
Yeah.
So, for the top, you know how we put we're looking at 0 from the right, and you have to do that again?
Thank you so much for making me a better math teacher. I should have been more specific. We're approaching 0 from the right. Thank you for that. Okay. Thank you. Everybody good? With the b to the negative 0.05x? Adrian, now what? Is that the answer?
No.
No, why not?
Just gotta keep going.
You gotta keep going. So what does that mean?
You gotta add well.
You're going to add the 1. So I'm going to take b e to the negative 0.05x, and I'm going to add 1 to it. Well, b e to the negative 0.05x was getting close to 0. So what's 1 plus b e to the negative 0.05x getting close to? 1. We are moments away from greatness here. Yeah.
Can you explain again why the 0 is going to the right?
I'll loop back around to that in a second. Is everybody okay up to here?
Yes, sir.
Final answer? I'll talk to that in a second.
Oh, okay, now I got it.
Okay, now the question is, what happens to a divided by 1 plus b e to the negative 0.05x? Jeanette, you got it? Okay, give me a second. I will loop back around, and I'm going to do that right now. Hey, I think I blew it. Okay, I want to go back to x is approaching infinity. Everybody was okay here? The graph of e to the negative 0.05x looks like this, is approaching 0, and Daisy said, shouldn't it be 0 from the right? Like, bigger than 0? Yes. Pretty good. What happens next in this function? I multiply by b. So b times e to the negative 0.05x, if e to the negative 0.05x gets close to 0, then b times that has to also get close to 0. But that's not the whole denominator. The whole denominator is 1 plus b e to the negative 0.5x. This part's getting close to 0, and I'm adding 1, so the denominator is getting close to 1. Now we were at the point where I want to look at the whole fraction. What happens to the whole fraction? We're taking a, and we're dividing by something really close to 1. Numerator is a, denominator gets close to 1, the whole fraction gets close to a. A is your limit. We don't know what a is. We don't need to know what a is. A is the limit. Henry.
So like, why, so you divide, a divided by all of that, and then why is it 1? Like, did you like pick a number, or?
Did I pick a number? What do you mean?
Because like you went from you went from a, and then you got a.
Hey. Were you okay that the be to the negative 0.05x gets close to 0?
It was just that last part.
If I look at the denominator, 1 plus be to the negative 0.5x has to get close to 1. My numerator is a. My denominator gets close to the number 1. Whatever the numerator is divided by something close to 1, what you're going to get is just the numerator.
Wow.
If you're not sure, try it on the calculator. Paul.
Would this be the same process if it wasn't
If you could plug in and just get a number, we wouldn't worry about this. All the friends are okay? All right, I want you guys to see what you can do with number 2. Number 2 has been changed. Sorry for the little bit of messiness here. I'm going to go to the sideboard, so Karina, if you could keep up with me here. Okay, limit as x approaches 5 from the right, square root of x plus the square root of 5 over the square root of x minus 5. Take a minute, see what you can do. If you want to check your calculator, feel free. Yeah. What do you mean? No, that was
Remember?
Okay, walking around, looks like some people have tried plugging in. Not a bad idea. But if you plug in, you get the square root of 5 plus the square root of 5 over square root of 5 minus 0. Which means 2 square roots of 5 over 0?
No.
Indeterminate form?
Not yet.
Not an indeterminate form. The only indeterminate form you guys know right now is 0 over 0. This isn't 1. So this is a sign to me I need to try something else. I can't plug in. Maybe it's a parent function. No. No, I do not know this parent. This is one ugly mother. Okay, yes ma'am.
So the plan's 1, but basically it's the radical x plus 5 over x.
Oh, so I hear you saying like you want to like multiply by the conjugate, like that fancy one? Mm-hmm. That would be something I would think if it was 0 over 0.
Oh.
And that's not what's happening here. Yeah.
Why can't you use the square root of x as the parent?
Why can't you what?
Use the square root of x as the parent.
Oh, okay. Yes, square root of x is a parent function. But then all these other things are happening too. My argument, Paul, is that no one actually knows. I'm pretty sure no one in the room knows what this graph looks like. Okay, Andy?
So if we plug in and we get 0 over 0, is it okay to just say it's indeterminate?
No, indeterminate form is not your final answer. Indeterminate form says, oh, I need to try some algebra stuff. I need to like factor and cancel. Develop.
If you do that little line thing you're doing, and then you just count it as 6 because it has to be to the right of 5, and then you work it out like that. Is that correct?
Okay, what I heard you just say is, can I just plug in 6?
Yeah.
Now here's the problem. With limits, the limit notation says limit is x does what? Approaches 5. 6 is an example of a number to the right of 5, but you haven't approached 5 yet. You've got to get closer, 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 closer. Julissa.
So wouldn't we just like translate it 5 minutes to the right on the parent?
Yes and a little bit of no. The problem is there's all these other things happening too. Okay, friends, I want to cut off the questions. These are great questions. Keep them coming, but not right at this moment. All right. So we tried direct substitution. It didn't work. This is no one's parent function. Some of you maybe tried this on your calculator and saw something happening there. Let's try it this way. Let's talk our way through this. X is approaching 5 from the right. Some people I saw said, well, let me focus on the denominator. Talk to me about the square root of x minus 5. X is getting closer to 5 from the right. As Yvel said, 6. But I got to get closer. 5.1. Closer. 5.01. 5.001. We know how to play the game?
Yes.
What's happening here? What's this guy converging to? SC1, SC2, SC3. Jeanette?
To 0.
You're going to be getting closer to 0. Positive or negative? Like from the right of 0 or the left?
No.
Pick a number a little bit bigger than 5. 5.1. 5.1 minus 5 is like 0.1. The square root of 0.1 is close to 0, and it's positive. Yeah.
Is that the graph that goes like?
Yes, this is a parent function that's been transformed 5 spaces to the right. Henry.
So whatever, like, so the 5 is from the right, right?
Uh-huh.
Okay, so then that means, like, every single other problem we've done, the starting number, the direction is going to end up being the one for the other number, the direction.
So are you saying the starting number is 5?
Yeah, so let's say it was like infinity from the left, like
Yep.
the next number will be also from the left, right?
Correct. Yes. Is everybody kind of okay with the 0?
Yes.
Now here's the thing, not the answer. So not the answer. That tells you what's happening in the denominator. But what about in the numerator? The square root of x plus the square root of 5. X is getting closer to 5. This is getting closer to square root of 5. Square root of 5 plus the square root of 5 gets closer to 2 square roots of 5. What that means, if I put it all together, is that the square root of x plus the square root of 5 over the square root of x minus 5, the top gets close to 2 square roots of 5, the bottom gets close to 0, but from the right. 2 square roots of 5, whatever that number is, who knows, who cares? Divide it by something close to 0. It's not going to get closer to 2 square roots of 5.
It's gonna get closer to 0.
If you need to check in your calculator, it's totally okay. Take out the calculator, try it out. Find 2 square roots of 5 and divide it by something close to 0, you know. Close. Like 0.0001. And see what happens on your calculator. 2 square roots of 5 divided by something way close to 0. From one person. What are we getting? 2 square roots of 5 divided by way close to 0. What you should see happening. Is it getting big?
Yes.
Positive infinity.
Oh.
So the answer that I want to see written down, limit as x approaches 5 from the right of the square root of x plus 5 over that stuff there. Your final answer. Positive infinity is one way to say it. The College Board way does not exist. Why?
Unbounded behavior.
Because of unbounded behavior. Okay. Before anybody totally freaks out, we're gonna change up the energy in the room. Paul.
When you plugged in the 5, like right there, you got the same thing as what you did. So like, is that a coincidence?
It's not a coincidence. We can talk about that more later. Karina.
The reason that it's positive infinity is it because there's a unlimited amount of, you know, like you can go like smaller numbers.
Right, you're always going to be getting smaller numbers, but those numbers that you're dividing by are positive. You know?
Oh, no, never mind. The
Okay.
last thing you said sounds
Okay, here's what I want you guys to do. I think just about everybody is sitting next to somebody who is their partner. I need you to link fingers with this person. This is the only person that you get to work with. Can I get Sylvia? Maybe you move over here with the ladies so everybody has a partner. You need to link up. You need to link pinkies. The person that you are linked with right now is the only person you get to talk to for the next 10 minutes.
Okay.
Today's date is August 18th. Whoever has the birthday closest to today, you are partner A. So figure out in your partner here. Some of you are like holding pinky fingers and staring deeply into each other's eyes. Yvel, it's a little weird back there. Okay. Birthday closest to today, your partner A. The other person, partner B. Partner A, here's the thing. You're going to work through these three problems. The only person you're going to get support from is partner B. What I want you to do, work through your three problems as best you can. If you want to use a calculator first, totes, okay. But then I want you to try the graphical analysis approach. And then get some feedback from your partner. Is everybody clear with the expectations here? All right, let's get rocking and rolling.
Oh, but this is mine. You could put going down.
You could be partner.
Don't cheat on your partner. The sign of an unhealthy relationship.
Oh no.
Go step by step.
Yes, he called me.
Then I have to do the
Hey, so this is the negative x squared. Your partner. That it goes down, right?
So the negative x squared, I know it's like this, but then would this be negative infinity coming from the right over
Oh
the
my God, you're still on this. A, B, move on. I don't care. A, B, move on.
You saw how hard the question was, it was like that.
and then finally one becomes smaller and smaller and smaller.
Okay, I have a question for this one. Okay, so it says as x approaches infinity, x squared is going to approach positive infinity. And then plus 6 is also going to approach positive infinity. But then I get 1 over. Oh, I understand that. Okay. We're going to get 1 over positive infinity.
would end up being infinity.
No, because it's on the bottom. X squared it approaches 1.
Is it infinity from the right or infinity from the left?
Like if you ask the 1 over it, like the square root of x or does the graph like instead of like cos of x, instead of being about turn to negative 1? It's 1 over. Oh wait, no. So the math is
plus 6. Or negative. So
oscillation.
as x approaches infinity. As x approaches infinity.
But didn't it move?
Or go the other way.
So would it be 6? I mean,
Good.
One.
What an expertly designed activity. Okay, like this. There's a domain restriction. Pay attention to the domain restriction. Hi, Sylvia.
Well, I played like if I was playing it in.
Love it.
X squared would approach positive infinity.
Love it.
And then x squared plus 6 also approach positive
Love.
infinity. But then you get 1 over positive infinity.
Yeah, so what happens there?
And so if 1 is being divided by a bigger number, it's going to get smaller, so it approaches 0.
Bam!
I was afraid I was going to stab myself. Oh, no, that's going down.
Oh, I understand it. Okay, do you get it? Okay. So it's approaching. So you understand how all of this is approaching positive infinity, right? So if I have 1 and think of just numbers that are getting bigger and bigger. Let's start at 10. 1 over 10. It's a really small. It's 1/10, right? 1 over 100. 1 100. So if I keep on getting bigger, it's just gonna get smaller and closer to 0.
the infinity was coming from the right of the
On the page right now. Still in my space, I'm in AV calculus, alright?
So what is the square root of x? In other words, what is square root of x versus I?
Because the x value that you're interested in is getting closer to 5.
How hard you try?
Something close to 5 minus 5 is close to 0. And then you take the square root. Alright, if I can get everybody pulled together, if all went well, 1A, 0.
Oh.
Partner B, also 0.
Oh no.
2, and now we got dabbing happening.
Oh, you saw that one?
Of course, I pay attention to you all the time, son. Okay, 2A and 2B look a lot alike. A lot alike. And I want to talk through this real quick. X is approaching 5 from the left. Think of an example of a number to the left of 5. Like 4. 4, but close to 5. 4.9. 4.99999. What would happen in this function? Close to 5, but smaller than 5 minus 5
A negative number?
is a negative number. The square root of a negative number does not exist. It is undefined. So the answer here, 1 divided by something that doesn't exist, we're going to say does not exist, but the reason? Because of a domain restriction. Bam. 2B, same problem?
No.
No.
Jose, why not?
Because in this case, the x is the one that's negative.
X is getting close to 5 from the left. Again, 4.9. 4.99. 5 minus 4.999 is close to 0, but positive this time.
Yeah.
Square root of close to 0? Close to 0. 1 divided by close to 0?
Bigger number.
Big number.
Positive
Big
infinity.
infinity, or does not exist because of unbounded behavior. Are most of you starting to feel a little bit better about this?
Yes.
Good. Okay, number 3, let's see. X approaches 0 from the right. Pi times something close to 0 from the right is kind of 0, right? What happens on the sine graph when I get close to 0?
Oscillate.
When you get close to 0. Oscillation is the ends. It gets close to 0. 1 divided by close to 0 is one of the infinities. So it does not exist, unbounded behavior. For the friends over here that had x approaching 0 from the right of cosine, x gets close to 0 from the right. Pi times close to 0 is close to 0. But on the cosine graph, if you get close to 0, you're getting closer to 1. Numerator is 1. Denominator gets close to 1. Whole fraction? 1. Curious, how many guys on year 3 went 3 out of 3? 2 out of 3. I can deal with 2 out of 3. And generally, I think we're starting to feel a little bit better. Okay, keep going with this next set. If you were A before, you're still A. Henry, I'm coming in just a second. Oh, I'm coming in. These are harder. Good luck.
Don't cheat on your partner.
Don't cheat on your partner.
Because this is going to be close to 0.
I understand.
Correct.
I do turn it off when it used to. Oh my god, I'm ready for this. Oh my god.
So I heard you say X is just 1. So if you're close to 0 from the right, what happens
Oh, so it's always not what it is.
Oh, all you have to do is just close the sign. Thanks, Benny. Let me quizzes. Okay, BC friends, quizzes are getting turned in. The smartest thing the 7 of you can do this weekend Watch another video. Keep going. Hey, the expectation is that every night you're watching a video and creating video work.
I was confused.
And what I'm going to do is start making sure that my solutions are like in a binder available for you guys so that you can check and get some feedback. Somebody had a question for me. Just close it all the way.